Perfect. Cool. Hey, I love the microphone cut, by the way. I really do. It's pretty good. Well, everybody, thanks for joining me today. First thing in the morning, love that, kicking it off. So hopefully you guys got a little bit of coffee. Try not to bore you at all. My name is Brandon Bozarth. I'm with Buzz Solutions. A little bit about myself. I've been working in the utility industry for about 12 years. Started off doing programs for load reduction, commercial, mostly in LED lighting when that was kind of new for us, getting rid of all those fluorescent bulbs, and then eventually found myself as a relay tech with XL Energy. Spent about 4 years there as actually a contractor through Power Engineers. So now I refer to myself as a reformed relay tech. Got out of the field, and now we're helping folks find defects on transmission, distribution, substations, solar, and we're growing from there. And today I'm going to talk a little bit about AI, where it's been, where it's going. I'm going to talk a little bit about Power AI itself, share a case study that we did with AEP, mainly working with Patrick down in Texas. And then I want to leave you with a little bit of information about kind of what you might look for in an AI platform. We're certainly not the only one out there. And truthfully, at Buzz, we want the industry to be successful. That's our main goal. If you use Power AI, that's great. That's certainly our preference. But we understand that utilities are going to try everything out there. And so the main thing that I hope you take away from this is kind of what makes Buzz Solutions different and Power AI different. But also, if you are evaluating other platforms, what to look for in those platforms before you jump in and start investing your money into it. So with that, we'll kick things off. Who do I wink at for slides? Okay, cool. Thank you. So really the main question we've been asking at Buzz Solutions for a long time now is what happens after the flight, right? How do you take action on these pictures that we're taking and all of this data that we're getting? And really that's where Buzz started, is what happens next after that. And as we'll kind of explore here, that wasn't quite enough. We needed to answer some questions before flight and after the processing as well. So that's where we started and where we're going. So we'll talk a little bit about the maturity curve of AI. So you guys have probably been using it for some time, especially I know the Grizzly Bear team is not strangers to it. But where it started was just manually reviewing all the imagery, right? Even though we had AI detections, it wasn't quite mature. We needed to explore the imagery and go through it and build trust. And so we were doing early pilots just to prove that AI could find defects. I mean, it really started off with the challenge wasn't identifying the equipment or whether we could identify a crossarm, but could we actually tell you the condition of it? And could we give you actionable insights that would allow you to do things with that information in the field? And today we've moved on a little bit. So we're in a closed loop AI workflow, and I'll talk a little bit about that in some of the next slides. But we're having experts review this information now. And so where it started off, it was just folks in our labs identifying these. Now that workflow is taking professional inspector information, the real experts, and putting that knowledge into a model. And we think that's a really important aspect of AI, is that we don't just see it as a tool to identify things, we actually see it as a store of knowledge. And as we know in our industry right now, there is a huge skills gap that we've been dealing with for a couple of decades. And so we have a lot of folks with all of our industry knowledge. They know everything about our systems, and they're retiring, which is great. We certainly want them to relax after a long career, but we also have this knowledge gap where new folks coming into our industry are not able to absorb this information as fast as we're losing it. And so what we see with AI is that that is a way to store that industry knowledge in models for the future. And so the working in a closed loop with these subject matter experts who are helping to train the models, helping to put that knowledge and store it as part of a utility's information for the future. And we're seeing it used as a training tool as well. So people are using these AI models to say, hey, here's things that our experts have identified. Now it's being found in this imagery, and we can use the models and the platforms to get new people on to view this imagery and to understand, what's going on. Some detections, some issues are very hard to find and understand. It's a lot more than just cracked insulators, and so we can use that as a training method. And where it's headed is certainly we're heading towards a lot more than just defect detection. We really see that this inspection data is becoming long-term asset intelligence. And so as you start to collect imagery about your entire system, you can ask big, hard questions about it. And so some of the things that we've done with Dominion Energy, for example, one of our first pilots with them was asking, where are all of our polymer insulators across our entire transmission system? They were identifying that the manufacturer's suggested lifespan was not quite accurate. And they had tens of thousands of structures where they wanted to find these polymer insulators and replace them before they failed. And those are not questions that you could traditionally answer without imagery especially. But as we collected this data and you had 10 pictures per structure across 70,000 structures, nobody wants to review that. AI was able to accomplish that task with almost 98% accuracy across the entire system with just a few hours of processing. And so as we kind of explore our platform today and some of the things that you can do with AI, so people are using these AI models to say, hey, here's things that our experts have identified. Now it's being found in this imagery, and we can use the models and the platforms to get new people on to view this imagery and to understand, what's going on. Some detections, some issues are very hard to find and understand. It's a lot more than just cracked insulators, and so we can use that as a training method. And where it's headed is certainly we're heading towards a lot more than just defect detection. We really see that this inspection data is becoming long-term asset intelligence. And so as you start to collect imagery about your entire system, you can ask big, hard questions about it. And so some of the things that we've done with Dominion Energy, for example, one of our first pilots with them was asking, where are all of our polymer insulators across our entire transmission system? They were identifying that the manufacturer's suggested lifespan was not quite accurate. And they had tens of thousands of structures where they wanted to find these polymer insulators and replace them before they failed. And those are not questions that you could traditionally answer without imagery especially. But as we collected this data and you had 10 pictures per structure across 70,000 structures, nobody wants to review that. AI was able to accomplish that task with almost 98% accuracy across the entire system with just a few hours of processing. And so as we kind of explore our platform today and some of the things that you can do with AI, I think a lot of times we're thinking about it as finding that defect, finding that one thing that's going to cause a potential failure. But one thing that I always say when we're talking about AI or we're going to move into some sort of program together is think about those big questions like that. What can we do? Some of the questions that we're trying to answer with Patrick in Texas, for example, are where are all of my pole mount transformers across my entire distribution network? That's a really hard question, but AI can scan these images, tens, thousands, hundreds of thousands of images in a matter of minutes or hours and can map those things to your GIS records and give you kind of an instantaneous result. Now, it may not be 100% accurate at the end of that. You still have to have humans in the loop. You still have to have experts review this data. But it gives you the ability to really kind of rapidly get to where you want to go. And so we see it as a really powerful tool to answer big questions. And we want to get from condition informing our maintenance strategy, we want to get to the condition of our system informing our maintenance strategy. So instead of being reactive and waiting for an outage to happen and then maybe discovering that something's wrong, as we collect imagery, we store this into these models. We push that information out to our GIS records, to our asset management records. We can start to be less reactive and predict what's going to happen, especially as we collect this data constantly using autonomous flight and things like that. We can notice subtle changes over time. So our maintenance programs can go from a reactive state to more of a planned state as we understand how over time our system is degrading as certain manufactured elements or equipment is failing, and we can start to understand those things at a deeper level. And we want to go from reactive to predictive, and then eventually to a state where we are not really reacting or predicting, but we just know the state of the system at all times. And that's going to take a lot of data collection. And so all of our drone friends in here today, it's obviously a big part of that. That's why we're seeing this push into autonomous flight. But I think it's a really important advancement in technology. And it's really interesting because, years ago, we were not able to understand this. I mean, it's the world's largest machine that we've put together that we maintain every day. And we're sitting inside of it, not really fully knowing what's going on. And I do believe that in the future, that will not be the case. We will understand our entire grid, we will understand its state at all points in time, and we'll know exactly how to keep it operating at a high level. So Power AI started in kind of the section 3 and section 4 here. Very, very simple AI detections with human in the loop. That's always been a part of it. We've always believed that the true perfect use of AI involves humans. Some of the studies that we've done, AI versus human, we've found that you guys are subject matter experts, you're professional engineers, you're linemen, you know what's going on when you're looking at this imagery. And so the human is 100% accurate for about 2 hours. And then it gets incredibly boring reviewing imagery. And you're thinking about your kid's softball game and what you're going to do this weekend. And that's fine. That's human nature. But the AI in the machine does not think like that. Unfortunately, the AI doesn't have kids, doesn't have a life. It just sits there on the cloud doing its thing. So the AI accuracy for a majority of our models is around 90% on most imagery. But it can do that 24/7. So when you pair that with the human experts, that's where we see you getting to your 100% review, your 100% efficiency. And that's really why we've always had a human in the loop, and we still believe that. I never tell people that AI is going to be 100% accurate, and that's not even our goal, as a matter of fact. So if I say that to my data science team, if I even mention 100%, they'll kick me out of the room. So, but we've built on that. So we realized that we needed to do more. And so we're working on an end-to-end workflow, and a lot of our latest features and things that Power AI can help with is really beyond the models. And this is where we're getting into things that you might want to look for in an AI platform and things that Power AI does today. So we knew that we had to help with the GIS and asset mapping aspect of it. So Power AI has a feature called Auto Match, where we associate all of the imagery that you collect to your GIS records. That's just the click of a button. So we're taking all the metadata from your imagery, we're taking your GIS information, we're running trigonometric functions on this data, in order to associate that to your GIS records. But more than just the association, Power AI is the ability to show you which records might be missing. So we're using that photographic evidence that you guys are collecting in the field to help your other teams at the utility. So it's a lot more than just an inspection record. It becomes a powerful tool that can be shared across the whole organization to help out. So GIS and asset mapping was important. And then also, we've moved into assisting with the flight and capture itself. So we understand that with autonomous drones, a big part of the challenge of deploying those is actually creating the flight plans. We've developed some tools that can take your GIS records and can create flight plans for Skydio Cloud, for Wingtras, for really anything. We export those into a JSON format that's compatible with your platform. We can help to develop those flight plans. And we consult on data capture methodologies. So that was one thing that we learned was pretty important to our customers as well, was that we go to Drone U and we learn how to fly the drones, and we're really good at it. And we're flying them all around. We're not crashing them. That's great. Great step forward. But then we have to think about this other aspect. You're flying a camera, and that camera is what's capturing the data. So just as important as flying the drone, it's important to understand that you are now a photographer. We need to capture good data to get it into the models. We don't want to store blurry images or overexposed images. It's a waste of our resources, right? It costs a lot of money to store terabytes and terabytes of information. And so we're helping to develop the best data capture methodology. We also have QA/QC tools that happen before the AI processing that kicks out blurry images, that kicks out images that are not to standard. And NIPA is a good example of an organization that's taking full advantage of that today. They're using that tool to not only kick out the bad data, but also to train and keep their pilots sharp. So it gives a rating to every image that comes into their system. Simple A, B, C, D, pass, fail type of score. And they can use that to say, hey, last week you flew this flight, you had a score of about 80%. And what that's doing is it's comparing it against NIPA's data capture methodology. And that can be applied anywhere. And that's an important aspect of this. Best data in gets the best results on the models. And then what do we do after we get these insights? We started exploring heavily with Esri. Our out-of-the-box Esri integration is one of the most important aspects of our platform. It allows us to take that data and push it into another platform with very, very powerful tools that help to analyze that data and do all sorts of things with it. And we're not building that ourselves inside the platform. All of these things that we see here need to be flexible because you guys have already made the hard choices about what you want to use, whether that's Esri or Small World, the types of drones that you want, the types of work management systems that you want. And so we remain flexible and work with any of those. We have open APIs, front end and back end, meaning that we can pull data from any source and we can push data anywhere that it needs to go. And we found that that was very important to our utility customers in order to support them. And so value starts really before the first detection. Like I had mentioned, it's about capture standards, flight planning, quality checks, being able to associate the data and move it along, and then create a lasting data set. And so as we collect these millions and millions of images, we think that this really could become some of the most important data that a utility has about the system. And so we want to treat it as such. So we're purpose-built for the grid, and I do want to emphasize that. This is one of the things that I think that you should be looking for in AI platforms. We only serve the electric utility industry. These models are not easy to build, and there's no reason to be distracted by anything else. We're not working with water. We're not working in oil and gas. We're not working on roads. We're only working with electric utilities, and we're only working for you. As I mentioned in the beginning, I come from utilities. A lot of people at Buzz Solutions do. I think that gives us a really unique view into your challenges and helps us to support you much better. And we're tuned to your use cases. We have a customer advisory board that meets annually with all of our customers that are invited to come, and they help us to align our roadmap. And when we do that, we are taking everybody's data who is opted into our data sharing program, who is part of this partner network, and we're all training the models together. So it allows for a more rapid development. We release new models every 5 to 6 weeks, so you're constantly seeing that improvement happen. And we know that we're doing it together, and it allows us to create a network where we can share information. So Dominion, AEP, NYPA, and others are working together to solve the same challenges. Of course, we have different unique challenges, but overall there's a lot of overlap, and we want to solve these problems together and do it quickly. And we're completely image source agnostic. We train on a wide range of data, so it's not just drones. You can bring your historical data from helicopters, fixed wing, anything else. And we don't want to pin you guys down to one way to capture data. We want you to be able to use all your tools available and have the same results with the AI models. And we stand up new models in a matter of weeks. So we have lots of different techniques that we've developed, including using generative AI for some of those really hard to find use cases. Think fires in substations. Nobody's let me start a fire in a substation yet to train a model. You pretty much have to use generative AI for that. Or smoke machine, which we've been planning to do with Dominion here soon. So some pretty fun stuff, but the point is, we knew that we had to stand up models quickly and show results fast. People can't wait a year if they have a use case that is really important, so we move quick. And we're built to work alongside your program. So Grizzly Bear team, we love in-house AI models. It's something that we come across all the time. It wouldn't make sense to compete against those teams. And so we are set up to support that, whether that's our models being served over API or whether that's bringing in-house models to our platform and serving them along ours. It's a team effort here. We're completely about that. And working with those teams. So open integrations right out of the box, Esri ArcGIS, Skydio Cloud, soon to be Wingtra Cloud as well, soon to be working with Census and the cloud that they develop. So it's important to have these out of the box connections. You want to go into Power AI, you want to sign up, get in and get the work done. Those are out of the box. That allows us to implement in about 4 weeks. We have a goal of 30 days to first value. We are absolutely allergic to people buying our platform and not knowing what to do with it, sitting in a 1-year contract and not having results. So 30 days to first value is our goal. These out-of-the-box integrations are a big part of that. You're trained, you're up and running within about a week, and you're using the platform and getting great results. Human in the loop by design, we went through why that's so important. And your data stays yours. We know it's really, really, really important to you guys. There are a lot of platforms out there that will make it very difficult to pull your data back down, to delete it, to own it. You own it at all times. If you don't have a data lake, we will set one up for you. We think that's very important. These are your assets. This is your information that you're collecting. We're just helping you find things out about it. Can you go to the next one maybe? I know I'm coming up on a little time here. Next. Thank you. So I want to talk about a little bit about what we did with Patrick recently. And so we did a pilot. We analyzed 88,000 images, which was a lot. Soon it won't be. That'll probably be 1 day worth of images. But analyzed 88,000 images. We processed those at about 0.6 seconds per image. That's about to probably 60x with our new backend as we're building to support this large amount of data coming in from the autonomous drones. And we allowed the reviewers to act, not just look at it. So they were able to push that information out, generate work orders, and actually fix the defects that they found right away. And so building on top of that, we want to get to the next phase with Patrick and AEP. We are working to fully integrate with the census drone docs. We want to take that imagery in as soon as it lands, push that to where it needs to go, process all of that in near real time. And what that means is that inspectors in Texas will be able to show up in the morning, see everything that was processed from the census drones that were captured the day before, and immediately take action on it. And so we're still pretty early in the game. We're here with organized asset intelligence. We do believe that prediction is next, and then condition-based maintenance, meaning we know exactly why we're going out to the field and what we're trying to accomplish there. But it is going to take some time still. We need to bring in other data. What part of Patrick's vision is to bring in the construction units, information about standards, and be able to ask the next big question. We're very focused on wildfire right now as part of that program. And so just to paint the picture of what we will probably see next year if we're invited back and talk about some of the things that we did, we believe that we're going to inspect an entire wildfire region, thousands and thousands of miles, be able to identify exactly what those structures are, match those structures and their condition to the construction units, understand the condition and assign it a score. So imagine we give that entire region a score of, say, 8. And we will know that if we want to get that to a 10, we will need to do X amount of work. We'll have to procure this much equipment, and we'll know exactly what it will cost to do it because we'll tie that to your specific construction units. We'll know the crews in that area. We'll know the wages of those crews. And so when we need to go to the business and say, hi, business, I would like to get my system from an 8 to a 9 and achieve that perfect power score, this is what it's going to take to do it. This is how long it will take. This is what we'll need to procure. This is who will be doing the work. And so by taking all of this data, moving us into the analysis, prediction, and condition-based maintenance part of this future, we can really answer those types of questions and start to move into that. So here's the 3 questions that you should ask for any AI program, okay? Where is the workflow? Is this just analyzing images and giving me back results? What can I do with that after? Power AI helps you from start to finish. It's a complete workflow platform, integrates with everything you do, and so that's an important thing to look for. What is the feedback system? Are we taking models off the shelf? Are we deploying that? Or do we actually have a closed loop with our experts that are training on our data, that are putting their information into the system? And then how are we measuring success? So ask that about any AI provider. How are we going to measure success? We're going into this program. What are we going to find? What is going to be the ROI? What is the actual result that we're going to get from this? And really hold them to it. So that was all. I don't know how much time I left for questions, but thank you for your time today, and I appreciate it. And if we do have some time, I'll happy to answer anything for you.
Yeah, we have a couple minutes, yeah.
Cool. Well, thank you very much.
Any questions?
How does it handle map discrepancies? Say you're flying it out, you said that it'll detect stuff that's not there. I mean, say there's a lateral that's not even on the map. Will it issue PLNs to the poles that aren't there, or how does it handle that?
Yeah, so... Oh, yeah, absolutely. So the question is, how does our platform handle map discrepancies? So we call that our geo-rectification workflows. And what it does is it will, when we're writing to the GIS record, we don't overwrite any data. So we're creating what we call the inspection layer. And that layer will flag the discrepancy. And essentially what it will do is say, we have photographic and GPS evidence that there's a structure here. We see it in the picture. but it's not showing up on your GIS records. And it simply raises a flag that says, hey, GIS team, whoever's in charge of this map, here's some evidence that something's missing, and we believe you should rectify it. It's a two-way street with that API, so when they do rectify it, it shows up on the map the next time. But even more than just missing, it'll also show you if a structure is in the wrong place. So we believe, due to proximity, that this structure is the one that you intended to inspect, but your GIS record shows it 3 meters over. And so it'll tell you different things and flag those differently. Yeah. That's it's European feet. That's what a meter is, right?
Pretty damn close.
Yeah. Yeah. And so it'll flag those as different things. So missing structure or versus structure in the wrong place versus, hey, you nailed it. So.
Does it compare with the GPS boards in the GIS or the PLN or?
Yeah, so it's using a lot of different data points. So it is using primarily, of course, the GIS information, the GPS coordinates, but it's also taking in that drone information. A lot of this is, the nadir shot is not enough, right, to prove that. So what we do is we take the culmination of all the information from the drone captured imagery, and part of our data capture methodology is to get the nadir shot, but also 6 shots around. And the more shots you get, the more accurate that is, because we're actually, using the field of view to understand things as well. To kind of explain how we made this accurate, we actually built this alongside Intergy, and we used the distribution network in New Orleans, which is wild, right? And so we were finding all sorts of discrepancies in that. It was very challenging to match that. So right now we reran it with our AutoMatch 2.0, which is using all the new features that I'm mentioning. We were able to match all of their imagery to their distribution network with about 96% accuracy. Which was pretty good, because they're flying from across the street looking at things. You're getting multiple polls in a picture. So we take in a lot of data to make that accurate. Yep.
It's always a challenge.
Thanks.
Yeah.
Cool. Thank you so much, everybody.